Hello, everyone. Good morning, good afternoon, or good evening, perspective to where are you? Thank you for joining us for this webinar organized by the Canadian Geotechnical Society Young Professional Committee. My name is Rajit Dayaratna. I am a geotechnical engineer from St. John's, Newfoundland. I'm serving the CGS YP committee as a knowledge lead and will moderate today's webinar along with Alex. CGS YP committee initiated this webinar series to allow young professionals to enhance their knowledge in a range of areas of geotechnical engineering. We successfully conducted 3 webinars so far, starting in January this year. So if you are interested in listening to fast talkings, recordings are available on our YouTube channel, and I will post the link in the chat. Before we get started, there are few housekeeping notes. To avoid any disturbance, audio and video access has been disabled. So if you have any questions, please use the chat option. The presentation will take about 40 to 45 minutes, and there will be a brief Q&A session at the end. If you have any questions for speakers, please type them in the chat, and I will take them as they appear. Today we have a well-experienced geotechnical engineer with us, Mr. Marco Arrieta from Tech Resources. Marco Arrieta graduated from National University of Colombia in 2009 with a degree in civil engineering, subsequently completed a master's degree in geotechnical engineering at the National University of Colombia in 2011, and currently developing his doctoral thesis at Oulu University in Finland. A research topic related to developing a novel shear strength criterion for rock fills and waste dump based on pactal dimensions. PhD using UAV photogrammetry, organized complexity and chaos theory aiming to be used at real full scale. Marco has over 14 plus years of experience in open pit mining operations across South America, the Caribbean, and Canada. His areas of expertise can be summarized as geotechnical and rock engineering studies and project implementation. The fields of expertise include rock engineering, rock mechanics, and waste dump characterizations in hard and sedimentary rocks, site investigations and ground characterizations, excavation control, monitoring, instrumentation, and risk management. Also, geotechnical and rock engineering studies for mining and civil projects specializing in open pit slope design, 3D modeling, 3D structural mapping and ground characterization, assessment and management of slope instabilities and landslides, the strategic monitoring system for open pit mine operations, geotechnical investigations for rock mass characterizations, the hydrogeological investigation for depressurizations of slopes. You can see that we have, an expert in the field. So without further ado, I would like to invite Mr. Marco to start his talk on geotechnical engineering in open pits, learnings, challenges, and opportunities for young professionals. Over to you, Marco.
Thank you, Rajit, for that eloquent presentation. That sounds like a lot. So I will try to summarize actually for you guys my experience. The chat today will be more like about my personal experience and professional experience being in the mining industry for the last 14 years. So happy to share that experience with you and all the learning that I have and I will have in the future, of course. I will share my screen with you,
please,
guys, and just let me know if you can see it clearly.
Yes, we can, Marco. You go ahead.
Okay, thank you. So the topic for today is geotechnical engineering in open pit, learning challenges and opportunities for young professionals. As Rajit mentioned before, I have a bachelor's degree in civil engineering, a master's degree in geotechnical engineering, and I am a candidate for my PhD candidate with the Oulu University. I has been exposed across multiple countries, multiple commodities and different cultures, and that is what make me happy. Have the opportunity to share my knowledge and to share with people that they are really different than my culture. So that makes the geotechnical engineering quite enjoyable, actually. So I would like to start with a simple question, and with what is a geotechnical engineer? What does that mean? For example, I really like to define myself as just a simple person, to have a basic knowledge of engineering, that actually love to be outside and just watch for failures, watch for the ground behavior, how the ground look like. Is it going to be a small failure? Is it going to be a big failure? Is managed that failure? We have enough information to model that failure, and at the end, just to try to represent that failure or that ground behavior with colors and in a beautiful shape that you can see it like in the right part of the screen, with colors that is going to represent what is safe or not. But at the end, that beautiful colors just represent a model. That is just the best guess that we can make with the available data that we can have. But actually, the real question is going to be, okay, that red color is representative. Actually, the ground is behaving in that way. Actually, we can see it out of the field, and actually the people is going to be safe if we get close to that red hotspot. So based on that experience and based on that couple of questions that I ask myself every single day in the morning and every single day in the afternoon when I leave the site, I just came with this vision. What is a geotechnical engineer in open pits? So based on that, we can find like a safe production engineer, a monitoring and response engineer, design and reconciliation engineer, and a project engineer. And after you pass for that different roles, which one should be the next step? So I will go through each role based on my experience and based on what has been working for me during the last 14 years as a geotechnical engineer. So for example, geotechnical engineering can be a challenging position if you encounter like a huge failure like that one. But also you can find a really good guideline posted across the industry. In this case, I bring it to you like 6 books. They are from large open pit project, so they can give you an idea. They can drive you through which are the minimum requirement that you will require to address different risks. For example, if you are modeling, if you are just trying to understand the groundwater behavior, if you try to understand waste dumps or just weak rocks like coal related, or just instrumentation, and soon it's going to be a new book related with mine closure. But yeah, let's go and take a look at the different position that I has been doing across multiple countries, multiple commodities. And yeah. So the first one I call safe production engineer. Not that I call, it's commonly called safe production engineer. Basically, and usually, this position is the entry level when you are getting in the mining industry. Why the entry level? Because this engineer, we call them a field engineer. This is the person that is going to spend 90% of the time just out in the field. Doing what? Just looking for different signs of instabilities, for example. Or just looking if everybody's safe, if mine operation is following the guidelines that geotechnical department has been providing, if they are following the procedures, if it's a new ground condition, for example, if they are just developing the mine and executing the mine plan in where we expected that they are going to be mining in this week, for example, and where we expect that they are going to be dumping in this week. They are dumping in the right direction, in the right location, and in the right rates, for example. That the geotechnical engineer are providing that guidance and they are following the guidance. So this person, because this person is going to be out there, just making sure that the people is going to be safe, which kind of skills that person should have. So communication skill. We think the communicate ourselves is an easy. It's easy, and actually it is not. The people is understanding what do you want, what do you mean, for example. The people is understanding your recommendation. Which communication channel are you comfortable to use? An email? Email is effective. Radio? A message? In-person meeting? Online meeting? Or just meet with the person in the location that you are going to provide a recommendation, for example. Look in the slope, trying to explain the operational person why you are advising to take that path, for example, why to implement that control, and what is going to mean that control. For example, if you are looking at a slope and you have a rockfall risk, why we need to explain clearly the impacts or the consequence of that rockfalls to mine operation. Actually, because if you consider a rockfall is going to be a hazard that can kill somebody, even a small rock like this one. The communication piece is the main tool that the safe production geotechnical engineer should have in mind. What skill? Are you comfortable just spending 90% of your day out in the field? Are you comfortable just cooperating with another person? Having that face-to-face conversation, showing respect. Remember, a young professional is somebody between 22 and 25 years old, with between 0 and 2 years of experience. And you need to deal with somebody that have 35 years of experience in mine operation. So how you can explain yourself as a young engineer, why that person should accept and execute your recommendation based on what? And you will find really interesting that it's not based on which kind of knowledge do you have. Actually, it's based on, are you showing concerns because somebody's going to be exposed in the risk? Are you taking in consideration that the personnel that he's responsible for certain amount of personnel during the shift, probably is going to be between 30 and 100 person that he is going to be managing during the shift in 12 hours. So actually, you are expressing yourself in a way that you feel that he will feel that you are taking care about the people, or is because you have a technical knowledge and you want to express yourself that technical knowledge. So communication and human interaction is the basic skills that you look in a safe production geotechnical engineer. If you are trying to hire somebody, for example, and of course that person is willing to spend 90% of the time out of the field, just looking rocks and looking at slopes and chatting with people. That is really important. So how look like a safe production engineer day to day? For example, you are going to be outside, just standing in the ground. Sometimes here in Canada, it's really cold. Sometimes it's in remote location. So you're going to be standing there, looking rocks, looking at slopes, and just assessing the risk. There is a risk. How many people is going to be underneath that risk? Are we willing to accept that risk? If we are willing to accept the risk, which controls we should be placing to manage the risk? Okay, now it's not in the pit. notice in the waste dump, 300 tip head waste dump, and you are going to have a truck just standing in the crest. And in the crest, in the bottom right image, you can see that it's cracks. So which one is going to be your recommendation? How you're going to explain a 35 years experienced guy that has been working in this kind of environment for the last 30 years that he cannot put a truck just to stand into the cracks? Because he's going to tell you, well, 25 years ago, we was doing exactly the same thing that you are not allowing me to do today. So why I should be taking in consideration your recommendation? Obviously, you can say, oh, it's because I say so. If you don't accept my recommendation, you're going to be putting people in danger. And he is going to accept your recommendation, but he's not going to feel that he's working as a team with you. So trying to explain him the ground behavior in a really good way is going to be a really good skill that you will learn if you enter in a safe production role, for example. After you spend like minimum 1 year, hopefully 2 years in a safe production role, in my personal experience, I ended in the monitoring and response position after I spent 3 years as a safe production engineer. So monitoring and response, obviously, is sometimes you cannot access areas because you don't have access anymore, because the pit has been in a phase that you don't have access to the upper benches. Maybe you don't have access in a waste dump because it's really busy, because it's a lot of trucks, or because they has been dumping there and you don't have access anymore. So you install instrumentation. Instrumentation can be really accurate, and sometimes you can see with the instrumentation something that with the human eye cannot notice into the field. For example, with radars, you can see 1 millimeter deformation. 1 millimeter is just thing as one hair. So I bet if you go outside in a dusty area is an area covered by snow, or if a really difficult access area, that is something that you are going to miss. But that you are missing, the instrumentation can see it. And actually you can see trends based on the instrumentation. And you can make decisions as well. So usually you have two kinds of instrumentation. One is like early warning instrumentation that is going to be represented by trends that is going to affect the daily or weekly mine operation development. For example, you have an area that you know that is showing movement, and you have a TARP, a trigger action response plan, attached to that area. So the instrumentation is going to be looking effectively that area, and it's going to provide early warning to mine ops or to geotechnical engineers to make decision. And the decision is going to be really simple, like shoot down the pit, or it's a different kind of instrumentation, like it's a strategic instrumentation that is allowing you to see trends that is going to affect at long term the mine plan. Let's say you have a slope that is behaving quite well right now, but it's showing like a small displacement and it's showing like small trends that is going to be a concern in the future with future phases. So in that regard, the instrumentation allows to provide feedback to mine planning in a long range window. Usually after you spend 2 years in a safe production role, you can spend just 1 year here in monitoring and response. And usually take like 30% out of the field and 70% of the office. Why at the office? Why you spend more time in the office? Because you need to process the data, you need to analyze the data, and you need to provide recommendation to safe production role, to manage the risk, probably something that is a hotspot that it's showing today, and he need to go out to the field and check it and see what is happening and just advise mine operation, or provide recommendation to design an execution, design a reconciliation, apologies. Design a reconciliation that, hey, this is not affecting the weekly plan, but it's going to affect this phase in this moment on time. Which kind of skills commonly you look in a monitoring or response engineer? Logical thinking. Because why logical? Because remember, how you develop an open pit, you mine bench by bench from the top to the bottom, and in that logical way, follow with a sequence, you need to address your geotechnical concerns. So only you look in this kind of position, a professional that can have a logical thinking, a person that can understand the ground behavior and have a comprehension about what's mean a brittle failure, how a brittle failure looks like, how many benches can't just go up a brittle failure or a ductile failure. That is that kind of failure that is, they are like slow, but they are huge and massive, and because they are huge and massive, they move really slow, and they unlikely are going to bury somebody. But a small, brittle, fast failure is the kind of failure that can kill people, actually. Why a critical thinking? Because if you start to analyze trends in the monitoring data, you need to think in a small scale and in a big scale. I will show you an example in the next slide. And imagination. You need to use your imagination to try to recreate that hotspot, what probably is going to mean out in the field. And for example, yes, you have a huge red spot here, but actually mine operation is just here. It's just 30 meters away from the hotspot. So you need to use your imagination to place yourself. Where is the deformation? Where is the hazard? Where is the risk? And actually, where is the personal? For example, cracks, how it look like? Oh, the cracks look like in the field, like open cracks. But how it look like in the trends? What the trends mean? I has been just having significance like crest advance that they is going to represent a crack here in the field, and I can link it. I can link jokes. Can I link these peaks with the ground behavior? Or even better, where is my instrumentation placed compared with the cracks? Are the instrumentation placed in a spot that is going to allow me to see the ground behavior and to have a response? But the reason this role is called monitoring and response. You collect the data, you analyze the data, and actually you can see here, for example, you can see a red line with say no dumping, or dump short and push, and just keep dumping. So you place the instrumentation, you analyze the data, and you respond. You have a response based on the trends and on the data behavior. So for example, why this role is really important? If you see this in your office, this kind of behavior, you need to use your imagination to let's see, okay, if this peak is reaching this point, probably this is going to represent a crack in the field. If this represents a crack in the field, this slot here is active right now. So that means that it's trucks, they are coming from the pit, coming down, and they are just dumping here. So that's mean that it's going to be people just dumping into these cracks. So I, as a monitoring and response engineer, need to call my safe production geotechnical engineer and just make the awareness to him. Hey man, look, we have this behavior. in the white line number 21, that's mean that the path number 1 maybe have cracks. So can you please go there and confirm? And why you know that the ground is going probably is behaving in that way? Because you, as a monitoring engineer, already performed the safe production engineer role, so you can understand and you can link the monitoring data and the ground behavior. Actually, when you are in the office, your pit look like this. This is a radar data, for example. So you can see, oh, here's yellow, and here's green, and here is red, and here is black. So like the stoplight. Green means that you're okay. Yellow means that, hey, be careful. Red means like, hey, go out there, check, and evacuate people if it's necessary. And also, this beautiful, colorful map, you can see it in this way. Trends. What does mean trends? Okay, if it's steady and it's not progressing, that means that this portion of the slope is behaving quite well. But this one that is showing like acceleration for quite a long time, and just in one spot at a time, you start to see an acceleration. That means that something is happening there. Something is happening in that slope. So you need to aware your safe production engineer. So your safe production engineer can go out to the field and just check the ground behavior and have a chat with mine operation and say, hey, mine ops, in this spot, the radar identified that something is happening. We cannot see it, but definitely it's there. So please stop to work in this area, or please place a barrier, a physical barrier like a berm, just to prevent that the personnel is going to be close to that hotspot. So commonly the people, when they think in a geotechnical engineer position in the mining industry, they imagine this role. So this is called design and reconciliation geotechnical engineer. This person is the modeler. This person looks like the smartest person in the room. Is the equation engineer. This is the know-it-all engineer. So this person is like the shiny person in the room. But actually you will start to see, and you will commence to see based on my experience, that this person needs to be humble. Because this person commonly takes difficult decisions. Commonly take decision that is going to save money to the company, or it's going to cost a lot of money. They can make improvement based on data. They can make improvement based on modeling. But you need to be careful. Commonly, you expect that this person is going to spend 2 or 3 years in the position. Why? Because it's the transition between the ground behavior, the data analysis in the monitoring and response engineer, and he takes all this knowledge and put it into the models and try to predict how the ground is going to behave with the new pit shell, or with the new waste dump, or with the new data that you are going to be drilling each year. So common skill that you're looking in a person that is going to perform this position on site. Commonly you look people that have already experience, at least as a safe production engineer, not necessarily as a monitoring engineer. It's going to be a nice to have if you perform the monitoring and engineer role. Why it's really important? And you have a basic comprehension about the ground behavior. If you have a basic comprehension about the ground behavior, that means that when the model show you the results, you can just have a critical thinking about the results. The results make sense. The results are actually representing what is happening outside. And in this position, you will require a minimum and medium or advanced mathematical skills, because you are going to be dealing with stuff like this one: shear strength envelope, multiple data, lab results. What is an outlier? What is a valid results? You're going to be playing with a different equation, with different shear strength parameters. Why? Because this kind of equation and this kind of parameters is going to feed the model. Commonly, the design and reconciliation engineer deals with a multiple failure criteria. So which one is going to be suitable for your mind? Which one are you going to use? Because based on that decision, it's going to be like, the data that I'm collecting is useful to use that equation. The data that is coming from the labs is useful, is applicable or not, this criteria to model this kind of situation. And at the end, that engineer is going to have this kind of results. What the result means? That means nothing. That means that this is green, sorry, that this is red, and this is green. If the same geometry, if the same geology, so what is changing? Is the design and reconciliation engineer can tweak just one parameter, just one, and turns an invalid design to a valid design. And actually that person, if tweaks that parameter in a wrong way, can just put people at risk, because you are going to have multiple trucks, dump trucks, dumping in that area that usually is not going to meet the design acceptance criteria. And because one engineer made the wrong decision, even if that decision was just because was in a rush and not willing decision, or just because of lack of knowledge, can turn a not valid area to execute in a valid area, just tweaking one parameter. So this position, when you are going to be performing this position, you need to be really, really careful with your decision. And for the reason, you have a team. If you have doubts, if you have questions, just escalate the question and just trying to find a person that have experience, and he is going to provide you guidance about it. Sometimes that person has been experiencing that situation before, or have experience. He can be really useful and he can provide a really good guidance. The design and reconciliation engineers is the person that made the reconciliation about the ground behavior. For example, after you mine out one wall, that person is going to take that geometry, is going to take the ground behavior, and is going to try to find patterns or trying to find geological features or defects that actually created a problem during the mining in that level, and he's going to try to predict if the same behavior is going to happen in the next phases. So you can predict the ground behavior, and you can just advise, hey, probably this is going to happen in the next bench, and because we manage in a good way the same issue in the current bench, we can apply just the same controls. So you can aware to the safe production engineer that the same event that happened likely will happen exactly in this spot and following this mining sequencing. And because you give that awareness to the safe production engineer, the same awareness you can give it to the monitoring engineer. So, hey, monitoring engineer, likely this is going to happen. when happening in the current bench looking like this trend. So probably be aware and look for the same trends in this position when the mine is going to be mining or when mine operation is going to be developing this bench. And this is how it looks like a reconciliation, just the same as a radar. Green, yellow, red, and blue colors just indicating if you meet, if you exceed, if you undercut it one slope, for example. And you can plot the events. For example, you can see here, this is just a reconciliation map. And this is just a couple of rockfall that happen in this wall. So you can see trends. For example, kind of yellow, kind of geological features, kind of a couple of rockfall that happened here. So probably we are predicting that the same rockfall that happened here is going to happen here. And especially this is more yellow than this one. So you can make that prediction, you can make that call, and you can just provide guidance and to mine ops and to mine planning. And also that person can just assess the controls. Are the controls performing in a way that we predict that they was going to perform? For example, here is a rockfall. This is the runout distance of different rockfalls, and this is the current control that the mine has. So as you can see, 95% of the rockfall has been managed by the procedures and by the different geotechnical risk management control that we have been placing here on site. And you can just assess the controls. They adequate? Are they working really well? People are following the recommendation? If all the answers are yes, you cannot stop and you cannot like prevent that the wall is going to fail or that rockfall is going to happen. But what you can prevent is put people and put personnel to work or to perform any activity underneath that asset. So you as a geotechnical engineer here in the mining industry, especially on site, you can just work to protect people and to prevent that people is going to be working in areas that they are not safe. So, as a summary, the design and reconciliation geotechnical engineer provide recommendations. So, in regards to, do we require additional instrumentation based on the modeling piece? I'm confident that the model is showing me good results, or I need an external eye just to check and peer review my work. Do we require additional data? For example, if you start to feed the model and you start to check your data and you see that your data is really wide and have a lot of noise, maybe you need additional data just to reduce the uncertainty in your data. Do we have additional structural or geological data to feed the model? Is the modeling accurate? So if you need all this additional, the next question is going to be, do I have the budget to address all my concern? If the answer is yes, oh man, happy for you. You have the budget just to close your gaps. If the answer is no, you need to find the balance between what do you want, what is the minimum requirement, and where is you are going to end with the decision you're going to make with the approved budget that you have. And after all those questions, the project that the geotechnical engineer that managed the project, did you request it to that additional to the project geotechnical engineer? Have the project geotechnical engineer in his roadmap all these additional, for example? Big question like, if I have an uncertainty in the life of my plan because I consider that a geometry is not going to meet the minimum design acceptance criteria, how I can communicate that decision that is going to cost millions of dollars to the upper management? How I can just tell people that we are going to reduce the production because we need to kill a phase because that phase is not meeting the minimum design acceptance criteria? Are you making the decision based on solid data, or is based on crowd because you feel like confident in your model and you want to push for that decision because you believe and trust in the model? It's because you feel like you have a gut feel, you have a guess, or actually because it's the best decision and it's the safest decision to execute? And the final question, when you are in the geotechnical engineer role, because as you can see, that person has a lot of, let's say in some way, a lot of power to make decisions that is going to create a huge impact, positive or negative, that depends. So do I trust in the model results? Is the model validated? Did you have a chat with your safe production engineer just to validate your model, for example? Because your model is pointing you in the direction that is a red hotspot in this location. So the safe production engineer have the same feeling that you. Is the instrumentation and the instrument data showing that the ground is, that your model is representing the ground? So remember, all the models are wrong. However, some of them are really useful. Be humble when you perform this position. Just be humble. Remember, the model will be good as the modeler it is. If you feed your model with rubbish, your output will be rubbish elevated to the end. And you are trusting in that model just to make decisions. And the project geotechnical engineer, after you spend like between 4 and 6 years just performing the previous roles, you are going to end in this role that is the role that take all the gaps and try to ask for budget, commonly is capital budget, to execute the different project that is going to close the gaps. For example, let's say that you are going to develop a new pit and you require additional instrumentation for that pit, a new radar, for example, because you have 3 radars and you have one pit that is critical. You have 2 radars in that pit, 1 radar in another pit, and you are going to be developing an additional pit that is in a critical spot in weak rocks that you are experiencing already major failures in that pit. So let's say that your design a reconciliation engineer based on the model, just develop the model for that new phase, and actually the factor of safety in that new phase is 1.05. Okay, let's say it's greater than 1, it's less than 1.2, but we are going to execute the phase just putting different controls to manage the risk. One of the controls is a new radar, because that phase is going to add to the mine plan $50 million. You can ask for, I don't know, $1 million to place a new radar, but you need to plan for it. You need to ask for the money prior to execute the pit. But you need to somebody just to make all the capital project in a way that is going to be approved, and he is going to spend that capital project in a way that when you get the new radar, you are going to deploy the new radar and just to hand over that new radar to the geotechnical safe production and monitoring engineer. But you need to somebody that plan for it. So you need somebody that understands the mine plan needs. You need a person there that can work as a team member. You need to have there a person that can mentor, offer mentoring based on his knowledge. to young coworkers. You need a person that understands the budgeting, and you need a person that can imagine the requirements that the mine plan will need and can explain that requirements to the upper management, that they will understand why it's important just to budget capital for the different projects that the geotechnical department may require. So the next step, this is really funny. After you spend like between 6 and 7 years on site, out of the field, in the office, modeling, planning projects and executing projects in a successful way. Now I ended in my career that I was ready for a senior position. So it's different senior position. Is senior position at site that commonly you enter in the new area that is to manage teams, like similar to a senior supervisor, for example, or there is a senior position in the corporate office as a principal advisor, but you decide that you don't want to be on site anymore and you would like to use that knowledge and go and be a consultant or be a superintendent or be an independent advisor or be a principal geotechnical engineer. And to be a principal geotechnical engineer, you need to be humble because you will be providing your knowledge to junior engineers. Or who knows, after 6-7 years of being a geotechnical engineer, you ended like, no, I don't like it. I want to move forward and be a chef, for example. This is basically a summary of my experience. They are close to 14 years of experience, and this is the path that I followed in across these years. And believe me, I don't feel regret. I feel really happy. I has been working with really good geotechnical engineers with different cultures, with different experience, and has been just lovely. So, challenges for young professionals. Be on site, believe me, it's stressful. You have a 24/7 operation that they don't like stops. If you can predict the ground behavior and just in advance provide recommendation, that will be really useful. But if you identify right now a hazard that is not going to put people at risk, but it's going to stop mine ops, you need to explain in a really good manner and in a really good way why they should be like stopping, delaying operation, and just losing money. Daily operational issues. In a daily basis, you will encounter difficult questions, difficult decisions, and that could be really stressful and can overwhelm new engineers. Work-life balance. Operation never stops. There is a 24/7. So sometimes people will call you 5 o'clock when you are not in the office anymore. So you need to find that work-life balance that is going to be suitable for you, and you are going to feel comfortable just following that rules that the site has. Commonly, mine operation, they are not close to big cities. They are close to small towns. There is not so much to do in that small towns. So people, especially young engineers, can get bored in that. It's an age gap. For example, like I mentioned before, you have 55, 60 years old, real experienced operational supervisor, and it's us with 22, 25 years old trying to explain that guy that we have new procedure, we have new tools to make decision, and that tools is showing that the ground is not behaving in the best way, so we need to close the area. So that age, that gap in the age make like challenge the communication between young engineers and well experienced mine ops and even mining engineers. Mentoring. Surprisingly, for my surprise, is not a lot of mentors out there that they are willing to spend quite time trying to explain you what's mean, which challenge you will encounter in the mining industry as a safe production engineer or as a monitoring and response engineer. So mentoring is a challenge that the new generation is encountering in these days. And learning. You need to be willing to learn. And sometimes people want to jump from the university to design and reconciliation. And when the people make that decision and they are in an open pit mine operation, that is difficult. That is difficult because that person don't have the ground behavior understanding, and it's going to be a challenge for that person to learn and for us to try to explain them that ground behavior. From the modeling case. Opportunities. Because it's a huge gap in generation, it's a lot of position right now for geotechnical engineers. So for example, here in tech, here in the valley, in the L Valley, has been really difficult to find new geotechnical engineers that are willing to move to the valley and work here in a small town. So that is a lack of geotechnical engineers that they are willing to relocate in remote areas and learn this cycle. Be on site. Actually, when you are on site, you develop communication skill. You learn from people that has been here for 35 years that can explain you the ground behavior in a way that the model cannot represent. So that is something that you cannot find in a computer or be sitting modeling. Learn how the operation develop the mine and how you can just provide guidance, and your guidance will be part of that execution. It's really beautiful. It's something that I will not change for anything. Be on site, it has been a lovely opportunity for me. As I mentioned, operational skill, and actually, if you are willing to take the risk and come and work in the open pit mining industry, you will play with toys that definitely other industry don't have. For example, Arrieta. Arrieta cost it's more than half $500,000, and I doubt that other industry different than mining will have the budget to buy more than one radar, and allows that a young professional plays with that radar. That is something that definitely, my dear professional, you will not find in another industry, or unlikely you will find that opportunity in a different industry that is not mining. And insert data. Insert data is a new tool. Well, it's not new, has been here for the last at least 5 years, but usually is an strategic tool to use as a monitoring engineer to predict long and slow movement that is going to be like critical for the mine plan. Better salaries, that is not a that is well known. That is better salaries here in the mining industry. Progression. We have a plan for a progression for each professional here, and we have a well-established timeline if the professional just wants to develop in that way. And it's incredibly fun. And it's lovely. And you meet people from different cultures, and be exposed to different cultures is a really interesting way to learn and to have human skills. Well, that is all. Thank you for listening and open to questions.